Hi everyone, my name is Thomas Kim. Today is April 20th, 2020. This is my 23rd episode about the programming language C++ 20 standard. In this episode, we will learn how to use fold expression and the constexpr together to create powerful type functions. For more information about fold expression, please double-click this link. Fold expression was introduced in C++17 standard. So fold expression is new to most C++ programmers. These are new keywords introduced in C++20 standard. Up to this point, we covered the keyword concept and the keyword requires. In near future, I will also cover const init and constable, co-await, co-return, co-yield, these are for coroutines, and import and module, these are for module. From concept to constable, these are for compile time construct. These are lists for new features introduced in C++20 standard. As you can see, keyword constexpr changes quite a lot. Constexpr now supports virtual function, union, try-catch, dynamic cast, even type ID. Also, constexpr string and constexpr vector. Also note that in C++20 standard, support for non-type template parameters is significantly improved. That means modern C++ language expands toward compile time constructs. I will introduce more and more advanced compile time constructs in modern C++ programming. Please note that I assume you have watched two of my previous videos, especially episode 20, Variadic template type constraint, fold expression. Also, episode 21, Variadic templates, fold expression, concept constraints. If you haven't watched this video, please double-click these links. To follow my current session, I assume you have watched episode 19 and episode 20. Otherwise, you may not be able to follow my current session. By the time you watch this video, you can double-click this link and download complete source code. Without further ado, let's get started. Start Visual Studio Code. Open your working folder. Select empty space. Click this button. 023 Advanced Fold Expression. Hit enter. Click this button. adb fold.cpp. Hit enter. Ctrl V. Include talk play fun, output HPP, talk play fun, S stream, auto endl, talk play fun, endl, namespace, types, talk play fun, types, void test, type, list, int main. Copy the function name, paste it in function main. Here, template, type name, types, using unprocessed types, type, list, t, types, template, type name, types, using processed types type list t types. Please understand that types type list t is defined template type name types struct type list t like this. Now here using types 1 unprocessed int short float using types 2 processed float double. So unprocessed and processed are simply type alias for type list. Now stream. This stream object is overloaded. We can display types 1 we provide with an instance, and there we can put some message. Types 1, I will copy and paste. This is types 2. Types 2. Now start command prompt. dir cd 023 advanced fold expression cl ehsc std C++17 is also supported. adb fold.cpp fe m.exe clsm. Please understand that this types 1 has element int short float as member types. Also types 2 float double. Now we will try with the clang compiler. dir cd 023 advanced fold expression clang++ std C++17 is also supported. adb fold.cpp, don't forget ltbb or c.exe, hit enter. Clang compiler should also work. Please remember unprocessed and processed, these are just type alias for type list. Now I make demarcation here. We will use a function without function body. Template type name ts1 type name ts2. Now here constexpr. This constexpr is very important. Types type list t ts1 we have to expand ts2 we have to expand. This is return type. Now we use operator plus types type list t This is one operand. Types, type list t ts2. We have to expand. I made a mistake here. Operator plus is binary operator, so we need two arguments. ts type list 1, type list 2. Don't forget semicolon here. Now template, type name, types, constexpr, auto, add types. It does not take any parameter. Return type, we use fold expression. Types, this is an instance. Plus, expand, this is fold expression. We are calling this function operator plus. Now 댓글 type, we need parentheses, semicolon here. This is fold expression. We add up together these parameters. This curly brace is instance. This function does not have function body. This part is trailing return type. Now here void test, add types. Using t1 types, type list t short int. Using t2 types, type list t character wide character t. Using t3 types, type list t float double long double. Now we are calling this function add types. Add types takes parameter t1, t2, t3. We have to call this function. This is function. Using added types. Now DECL type. We convert the return type of add type into type. Now stream added types. Added types. Now we call this function copy paste. I will disable it in the command prompt. We build again. CLS M T1 short int, T2 character wide character, T3 float double long double, short int character, wide character, float, double, long double, all these types are merged together like this. Now let's try with clang compiler. We rebuild. It failed. Call to function operator plus. That is neither visible in the template definition nor found by argument dependent lookup. So argument dependent lookup kicked in. I will explain about argument dependent lookup in some future sessions. So here namespace talk play fun types. We find these two functions with the namespace talk play fun types because this type list is defined in this namespace. I will indent. Now scroll down. We have to provide types. Now we build again CLS. Now it should work. CLS C. Clang compiler also works successfully. I will discuss argument dependent lookup in some future episode. Now we will learn something really cool. I make demarcation here and the namespace talk play fun types and the namespace talk play fun types template type name types struct st subtract type primary template determines the count of template arguments. Template type name PS. PS means processed. Type name S. Type name unprocessed. Struct st subtract type processed PS we will put S here unprocessed S unprocessed tail. From unprocessed, this S is identical, so we remove this S like this using type name. We call it recursively S processed PS unprocessed US type. We call this subtract type recursively. I forgot parameter pack expansion because this type S and the subtract type S is identical. We removed S from this parameter fact. Template type name S type name ps type name head type name us unprocessed struct st subtract type s. Please note that this s and h are different, so we have to move h to ps like this. Processed ps unprocessed h us. Don't forget semicolon here. Using type name, we call it recursively s processed ps. Please note that s and h are different, so we move h to the tail of processed h. Now unprocessed. Because we moved h to processed, here we use us like this. Then type. Template, type name s, type name ps, struct st, subtract type s, processed ps. Now unprocessed. Unprocessed is empty. Please note that this unprocessed is empty. So using type processed ps. Now template, type name s, type name type list. Using subtract type name, we call this function copy paste. We provide s, this type. Now processed is empty. Then type list. This is unprocessed type. Type list is unprocessed type list. Don't forget type. Now we test this function. Void test subtract type. Using t1 unprocessed character int float double. Using t2 we call this type function. We subtract int from t2. Subtract int from this list. Don't forget types, because this type function is defined in namespace types. It should be T1. Now string T1, T1, and there. T2, T2. Now we call this function copy, paste. I will disable this function. Now we build using clang compiler. CLS-C. From character into float double, character into float double, we subtracted int. So character float double, int is removed. Now I will insert int here. Then we try with Microsoft compiler. CLS-M. From this list, character into float into double, integer is removed. Now here we define template, type name, type list, type name S, constexpr, subtract type. Please note that in case of subtract type, we have to provide S. Then type list. This is return type. Operator. This is subtraction operator. Type list, one argument, another argument. This does not have body, does not have function body. Template, type name, type list, type name, SS, constexpr, auto, subtract, types. Empty function parameters. Return, we use fold expression. Type list, we have to provide an instance. Minus SS. We have to provide an instance. We are calling this operator. Please note that we are using fold expression. This syntax. Copy, paste it here. And I will copy this text for your reference. Now scroll down. We call this function like this. Types, subtract the types. We pass T1 for type list. T1. We pass SS. We will remove int and float. Int, float. Please note that this is a function, so we have to call function. Now using T3 DECL type, we convert to type string T3 and there. We build again using clang compiler. Please note that we have two warnings. Warning comes from this operator. This is the warning message. Copy. I will paste it here. I will use some preprocessor. If def clang major and if copy this, paste it here. We use pragma clang diagnostic push. We save warning. We save warning. Pragma clang diagnostic ignored. We provide this warning string like this. Then we don't need it. Now here, pragma clang diagnostic pop restore warning. Now we build again. It built successfully. C. So from this unprocessed type list, we remove the int and the float. So we remove the int, and the float. So we have a character and double. We test using Microsoft compiler. CLSM. Microsoft compiler also works correctly. But I really hate this syntax. I will change it. Fn, scroll up, also Fn. Then scroll down. I will copy this. Copy. Paste it here. Template. Type name. Type list. Type name. SS. Now we paste type list here and SS here. We don't need types. I say subtract types T. Now copy this, scroll down, T int float. It should be T1. Using T3, don't forget types. Now I will disable it. We use Microsoft compiler. CLS Microsoft compiler works perfectly. We use clang compiler. CLS clang compiler also works. Now this syntax is pretty.